Hello and welcome to Morehouse's Math Menagerie. Today we're going to start out by answering some questions from you, our fans. Meredith, what's our first question? What do you mean we don't have any questions? Yeah, how can we not have any questions? Yes, Meredith, I know we only have 2 subscribers, but we should still have some questions. We'll talk about this later. Let's just go to the PowerPoint. Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today we're going to be talking about a 2-sample t-test for a population mean. Mr. Morehouse is interested in how often students are absent at the beginning of the school day versus classes immediately following lunch. In order to investigate this, he took a random sample of students in his first hour and 5th hour AP Statistics classes and recorded students' number of absences during the first semester. He wishes to conduct a significance test at the alpha equals 0.10 level to determine if there is a difference in the mean days absent between the 2 classes. Here is our data for first period and 5th period. Our first step is to set up our parameters and hypotheses. We're going to let mu sub 1 equal the mean number of absences by students in first hour, and mu sub 5 equal the mean number of absences in students in 5th hour. Now we have 2 options for setting up our hypotheses. We could first say that mu 1 equals mu 5, and for the alternative, mu 1 does not equal mu 5. Or we could set it up as a subtraction hypothesis. Mu 1 minus mu 5 equals 0, and mu 1 minus mu 5 does not equal 0. Either way is fine. Just note that this right-hand side with the differences is how the calculations are done. Step 2, we're going to look at our conditions and our procedure. This is a 2-sample t-test for mu 1 minus mu 5. We have a random sample of students from both classes. The 10% condition is met, and I showed the work for both the 1st and 5th period classes. Sorry for the typo here, this says 2, but it should say 5. Our normality condition for the 1st period class is a little bit tricky because we don't have 30 students. So we're going to have to look at a box plot to determine if a t-test is appropriate. For my 5th period class, there were more than 30 students, so the CLT applies. Again, my apologies, this should be n sub 5 here. So let's go over to Desmos and check the box plot for 1st period. Here I already have the data put into a table with my 1st period classes in X1 and my 5th period class in Y1. So let's make a box plot of 1st period, and we can see here we have a nice box plot with no major skewness or outliers, so a T procedure is appropriate. Please remember you need to draw this on your paper with an axis in order to get full credit for this condition. Speaking of plots, you may have heard of a box and whisker plot, but have you heard of a box and beard plot? To do our calculations here, this is the test statistic formula. You can see that it's rather daunting. We have the difference in our sample means, x bar sub 1 minus x bar sub 5, minus mu sub 1 minus mu sub 5. You'll recall from our hypotheses that we believe this is 0, divided by the standard error of the combined distributions. You'll see this is the variance for period 1 divided by the sample size for period 1 plus the variance for the sample from period 5 divided by the sample size from period 5. This would be quite daunting to do by hand, and we have good lists of data in Desmos already, so let's jump back into Desmos and use the calculator to do our calculations. All right, in Desmos, we can go ahead and hit the plus sign and inference. Now we're doing a t-test, and my first set of data is in the x1 variable. Now, since this is 2 independent samples, I'm going to put y1 under the second sample that's optional here in the t-test. When I hit create test, it's then going to run the test for me, and I can drop down this significance test menu and see that my p-value is 0.338 and I have a test statistic of 0.968. Please note that the degrees of freedom is kind of a weird number, that 41.59. The Desmos calculator or any other calculator is going to use a rather large formula that's a little bit complicated to find these degrees of freedom. We'll never have to use that formula, so I'm not going to show it to you, but that's why we end up with a decimal degrees of freedom. Now, to round out our problem, let's go ahead and write our conclusion. The p-value of 0.338 is greater than 10%. Thus, we fail to reject the null hypothesis in favor of the alternative hypothesis. There is insufficient evidence to suggest that the true mean number of absences in first period and the true mean number of absences in fifth period are not equal. Thank you for watching this video. I'll leave you with this stunning picture of the Norwegian curling team and their amazing outfits. Have a great day.